Today we're talking about quality. So, what is quality? Let's say I'm looking at my laptop. What makes my laptop a high quality product? Is it because it simply works? Is it because it looks nice? Is it because it meets some sort of engineering specification? Well, it's actually all of those things and more. There are different dimensions to quality, so we can talk about what those are. So, when we think about quality from the perspective of a customer, it's how satisfied they are with your product or service. But there's different levels of expectation and satisfaction with products and services. So, does it conform to my expected specifications? Does it have good value? Now, what is value? This term gets used a lot in business. It's not always used correctly. So, let's talk about it for a second. Value is actually the ratio of quality divided by cost. Now, when I say I want to increase my value, that means I can either increase my quality for the same cost, or I can maintain my quality and decrease the cost. Either way, I'm increasing value to customers. So, value from the perspective of a customer, a customer would want to see value at least be consistent over time, if not increase over time, for them to continue buying your product or service. We also have elements of quality like, is it durable? Is it reliable? Can I service it easily? Is there a good customer service that goes along with it? Do I like it? Does it look nice? These get into those psychological or personal opinion aspects of what quality is. So, once we know what quality is and we know it has different dimensions, we also have to think about what is a quality failure. Well, anytime I am failing to satisfy a customer, that is considered a defect, a quality defect. And we can track the defects over time. So we can track customer complaints. We can track, manufacturing defects. We can track breakdowns and quality problems in a manufacturing setting. But also, we can survey customers as well to determine if they're happy with services or not. So we can track defects and quality data over time. And we have to understand that quality and investment in quality and quality management isn't free. Like, it costs us something. So let's talk about what those different costs are. One of the most important costs, and what I would say is the most worthy of investment, is prevention cost. These are costs that are associated with you preventing a quality problem in the first place. So things like training employees to be consistent over time or to provide high quality work. Um, Making sure your equipment is well maintained so that it doesn't provide quality problems. Um, Making sure that you have preventative measures in place in both equipment and service settings to kind of guide the process to prevent quality problems. Those are all prevention costs that are usually worth the investment. And then we have appraisal cost. Those are the cost of actually finding a quality problem, assessing performance levels and finding quality problems. So these would be things like your quality control department or auditors or people who are actually coming in and checking quality levels of products and services. That costs money too. But those are both important to prevent both internal and external failures. Now, an internal failure still costs money. That means I found a quality problem and I have to fix it. So that could be lost product, that could be rework, that could be extra time and equipment time. So that's expensive, but the customer never sees it, and the customer usually never knows about it. And that's why it's called an internal failure. But we can contrast that to an external failure, which is so much worse. Because an external failure is when you determine there's a quality problem after the customer receives it. And this is all sorts of problematic because not only do you have the cost of the refund or replacing the product, but you also have potential problems like lawsuits or brand damage that's associated with external failures. And then ethical failures can happen as well. So, ethical failures can be internal to your company or along your supply chain. These are things like, bribing an auditor or intentionally falsifying quality data or using defective parts on purpose. Those would all be ethical failures that could jeopardize your entire company and brand. So, those are important both to internal operations, preventing those and stopping those problems, but also when we design our supply chains and purchase from suppliers, we need to consider potential ethical failure cost as well. So we understand that quality is important and we understand that there are costs associated with it. But how do I actually manage quality? Well, there's a philosophy known as TQM, or total quality management, that identifies that customer satisfaction should be in the center of our design and decision making. This allows for quality to flourish because we're considering things from the perspective of the customer. And then we also want to involve employees. We want employees to be involved in speaking up about quality problems. We also want their involvement in ways to improve and make quality better over time. So, getting their feedback and inputs on both problems and ways to be better are helpful to managers. And of course, we want continuous improvement for several reasons. First of all, our expectations of our customers change over time, and usually the expectation increases over time. So the quality level or the value that I expect over time is getting higher and higher and higher. And in order to be able to keep up with that, you have to continue to get better, both in your design of products and services, but in your actual delivery process design as well. So when we think about continuous improvement, we're thinking about taking our existing processes and doing the work better, designing those differently and making them more efficient and effective. So you'll see on the outside of these that support both employee involvement and continuous improvement, you have product and service design, process design, purchasing, of course, benchmarking of strong competitors, and problem solving tools that help us solve current problems, but also help us improve over time. In TQM, there's an improvement cycle called Plan, Do, Check, Act. You might also see it in other places listed as Plan, Do, Study, Act. It's the same cycle. And it's basically an improvement cycle of trying to plan which process where you're trying to improve. We then collect data and make improvements. And then we cycle again and again and again until we get to a state where that process is operating much better. Another improvement cycle that falls under quality management, I actually like a little better, and it's under the philosophy of Six Sigma. Now, Six Sigma is an improvement philosophy focused on reducing variability. And that's a broader concept of, when I think about all sorts of variability in my work, I have variable jobs, variable times, variable employees, variable machines. Six Sigma tries to reduce variability to make things more standardized, predictable, and have higher quality levels. So, as we're focusing on quality and we look at Six Sigma for improvement, we have this DMAIC cycle: define, measure, analyze, improve, and control. And the DMAIC cycle basically means I defined a problem or a process that I want to improve. Before I make any improvements, I need to really understand that process. So I'm going to collect a lot of baseline data. I'm going to talk to a lot of people. I'm going to really try to understand the current problem. And I'm going to analyze all that data. And then I'm going to make a data driven improvement decision. So I actually make a change, an improvement to that process. And then I'm going to see if it worked. I'm going to recollect data. If things are going well, I will sustain the change. And if not, I can do the cycle again. Now, Six Sigma is focused statistically on 6 standard deviations, so 6 sigma. And when we think about standard deviations, we're talking about a normal distribution, and standard deviation, of course, is in the tails of your normal distribution. And when we think about, what is Six Sigma statistically, it means your company would be defect free, your product or service will be defect free out to 6 standard deviations. Now, that is virtually impossible in practice. So, when we think about companies that claim to be Six Sigma companies, they're really claiming to aim for Six Sigma or aim for lower variability, higher levels of quality. That's the goal or general philosophy of Six Sigma. And when we think about improving using a Six Sigma philosophy, there's 2 different ways we can improve. So let's talk about that. The first is I want to decrease the variability or the spread within my process. So if I have a lot of variability in machinery or employees, and it is kind of all over the place, as you kind of see here in this graphic, I want to reduce that spread and make it much tighter. So I'm going to take the broad variability and try to reduce that variability to bring in the spread. I also understand that I can be off target. So even if I bring in the spread, it doesn't matter if it's not targeting my goals, my specifications, what I'm trying to produce. So I have to take that spread and I have to center it on my target. So a Six Sigma approach is looking at the way that I do my work, my processes, and I'm trying to reduce variability and also target on my specific goals. Now, one common method of taking data or learning about our process and defect rates are what's called acceptance sampling. So acceptance sampling is when I take a sample of a product or a service, but it's a sample, and then I check various quality metrics within that sample. And if everything looks good within the sample, I assume everything else is fine. So you imagine a production line making candy bars, and they're making 10 million candy bars a day. So it would be impossible to check every single candy bar for quality functions and quality data. But I can take a sample and collect that sample. And if everything in the sample looks good and checks out for my quality metrics, I assume the others in the same production run are also good. That's acceptance sampling. So statistically speaking, this works for most products and services to determine what acceptable quality levels are. It's not a perfect metric, so that's also important to keep in mind. Because you're only looking at a sample, you're not getting a complete picture of the full process. And we see that here on our next graphic, where sample means are much tighter in terms of distribution than the full process itself. So if I'm trying to really understand the process, I would either need more samples or I would need to look at the statistical difference between the samples that I'm looking at and the process as a whole. And as a manager, I need to understand the difference between my sample distribution and my overall process distribution that I'm trying to manage. Well, that's it for today. Next time, we're going to be talking about quality control and some techniques for that. See you soon.